Welcome back. Today we are doing Chapter 1, Lesson 4. This is 6th grade math. We're going to be talking about ratio tables today. The first thing we need to talk about are what are ratio tables. We talked about rate last chapter. For example, the number of hours that one works would determine how much they get paid. So say you make $15 per 1 hour. A table would look something like this, where we would find out how much you would make if you were to work, say, 2 hours, or 3 hours, or 5, or 10, or 15 hours. This is going to be a ratio. We know we get paid $15 per hour, so 2 hours would get us $30, because we did 2 times 15. 3 times 15 would give us what we would work in 3 hours, or $45. 5 times 15, 5 times 5 is 25, 5 times 1 is 5 plus 2, so that would give us $75 in 5 hours, and so on. This is going to give us our table. This would be 150, and then 15, 25, 75, 0, 5, and 1. That would give us 225. This is a ratio table, or even a rate table here. This is giving us all equivalent ratios. 1 to 15 or 15 to 1 is the same thing as 30 to 2, 45 to 3, 75 to 5, 150 to 10, 225 to 15. These are all equivalent ratios. If I were to take 30 and 2, 30 to 2 right here, and divide them each by 2, when I divide 2 by 2, I'd get 1. If I divide 30 by 2, I'd get 15. Same thing over here. 3 and 45 will both have 3 in common. If I divide 3 by 3, I'll get 1. And 45 divided by 3 would be 15. This makes all of these ratios equivalent. This here that we built is our ratio table. This will tell us how much another value will be depending on how further along we get. So let's look at the real world link here. A punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. So again, 1 container of soda and 3 containers of juice to make 1 batch of punch. Draw red counters to show the number of containers of soda, and draw yellow counters to show the number of containers of juice. You need to make 2 batches of punch. So, let's go ahead and get this to draw. Let's see if we can actually pick a bigger marker here. So I'm going to need 1 thing of soda to make 1 batch of punch. And I'm going to need 3 containers of juice. This would make 1 batch of punch. However, they wanted us to make 2 batches. Therefore, I'm going to need another thing of soda and 3 more things of juice. So, in this case, I would have 2 sodas and 1, 2, 3, 4, 5, 6 juices. If I were to divide both of these by 2, I'm still getting 1 to 3, which is the original batch. This would be my unit rate. Now, I know that the denominator is not 1, so technically it'd be 3 to 1, but it's still my unit rate. For every 1 soda, I'm going to need to use 3 things of juice. Step 2. Draw red counters to show the number of containers of soda, and draw yellow counters to show the number of containers of juice needed to make 3 batches of punch. So I'm going to need 1, 2, 3 things of soda, and for each 1 thing of soda, 3 things of juice. So 1, 2, 3, 1, 2, 3, and 1, if it'll let me, 2, 3. My ratio here will now be 3 sodas to 9 juices. And if I take 3 to 9 and divide it both by 3, I'm still going to get 1 to 3, which is the original ratio I had to begin with. 1 soda for 3 things of juice. Find the ratio in the simplest form of soda to juice needed for 1, 2, and 3 batches. What do you notice? Like we said here, 3/9, 3/9 or 3 to 9, 2 to 6, 1 to 3 are all equivalent ratios. The only thing that has changed here is how much punch we're making. So, to make a ratio table, again, our table would look something like this. S representing sodas and J representing juice. If I use 1 soda, I have to use 3 juices. If I do 2 sodas, it'll be 6 juices. 3 sodas, 9 juices. And then we can continue on to 4, 5, and 10. If I do 4 sodas, I'm going to need 3 juices for each soda, so 4 times 3 would be 12. I would need 12 juices. 5 sodas to make a batch of punch, I would need 3 for each soda, so 3 times 5 would be 15. And then 10 things of soda, I'd have 30 things of juice. This here is a ratio table. Equivalent ratios. The quantities in the opening activity can be organized into a table, which we did right here. This table is called a ratio table because the columns are filled with pairs of numbers that have the same ratio. 1 to 3, 2 to 6, 3 to 9 are all equivalent ratios. Equivalent ratios express the same relationship between quantities. Ooh, and there's already writing here, so let's go ahead and erase that. To make yellow icing, you mix 6 drops of yellow food coloring, 6 drops of yellow food coloring right there, with 1 cup of white icing, 1 cup. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So, if I do 5 cups, I'm just multiplying 1 by 5 to get to 5. 6 times 5 will be 30, so that would be our answer for that. Use the ratio table. We did that. So add, and then of course we could do it for even more, just like it had over here. I'm not sure what the numbers were, but we can expand. So say we're using 10 cups of icing. For each 1 cup, I need 6 drops of yellow. So 10 times 6 would be 60. Or what you could do is go based on the unit. 1 times 10 would be 10. 6 times 10 would be 60. And then the same thing can happen for other quantities that you want to find later on. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So if he ate 66 hot dogs in 12 minutes, which is highlighted right here, they want us to find out how many hot dogs he ate every 2 minutes. I'm going to divide these by different quantities. You see here that what they realized with 66 and 12 is they had a common factor of 2. That was their first step. Technically, 6 is a bigger factor, but when they do this, they realize that he ate 33 hot dogs in 6 minutes. They divide that by 3, common factor of 3, to get the 2 minutes. So he ate about 11 hot dogs every 2 minutes. If we wanted to find the unit ratio, we would divide 2 by 2 to get 1, and 11 by 2 to get 5.5. So roughly he ate about 5.5 hot dogs per minute, which is pretty insane. So let's see if we can do this got it part. A patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? So let's look at the chart. We're going to go ahead and zoom in a little bit. Every 8 hours, a person will get 1 bag of IV fluids. So from 1 to 4, there's a pattern here. I have to multiply that by 4. So I'm going to multiply 8 by 4 to figure out what my answer would be. 8 times 4 is 32. So it'll take 32 hours for this patient to receive 4 liters, of IV fluids. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. 12 cups, 16 cups. Find the amount of sugar needed for 4 cups of cranberries. Now, there is a middle part here, so I'm not going to automatically divide this by 4, because I know that 16 divided by 4 would give me 4, and then 12 divided by 4 we all know is 3. But let's save that. Let's divide this by 2 first. 16 divided by 2 will give me 8, and then 12 divided by 2 will give me 6. So 6 cups of sugar will give me, I will need 8 cups of cranberries. Then I'm going to divide these again by 2. 8 divided by 2 give me 4, and then 6 divided by 2 give me 3. This is a ratio table. So what it's saying is, reading it from left to right, for 12 cups of sugar, I need 12 cups of cranberries. For 6 cups of sugar, I'm going to need 8 cups of cranberries. For 3 cups of sugar, I'm going to need 4 cups of cranberries. And then we can continue on. So there is a relationship. What we are doing here is we are doing something called scaling. We've learned how to do this, but we've called it something differently. We've called this converting. Say I have a fraction 1/2. I've asked you to give me equivalent fractions. When you give me an equivalent fraction, you are just multiplying by something. Let's say we're going to multiply both of these by 5. This would give me 5 over 10. 5 over 10 and 1/2 are the exact same fraction. One just isn't simplified. What we did here is converting, but it's also known as scaling. We are scaling up, changing this fraction up. So let's go ahead and start this over. Let's say we're at the county fair. For every 1 dart thrown, on average, I'm popping 2 balloons. This is my ratio table. If I threw 2 darts, 3 darts, 4 darts, and 5 darts, how many balloons would I pop? Remember, for every 1 dart, 2 balloons are being popped. 2 darts being thrown, I'm going to pop 4 balloons. 3 darts, 6 balloons. 4 darts, 8 balloons. 5 darts, 10 balloons. 1/2, 2/4, 3/6, 4/8, 5/10. What I did here is I scaled, and I actually scaled up, making the numbers bigger each time. If I were to throw 6 darts, I would get 12 pop balloons, scaling it up even more. That is upscaling. Downscaling would be if I did something like this. Let's say I'm still at the county fair, and it took 10 tickets for me to play 4 games. Cost me 10 tickets to play 4 games. This is my chart now. Actually, I don't like that. Let's change this to 12. That'll make it easier. How many tickets does it cost me to play 1 game? What I'm doing here to find out how much this would be is dividing by 4. Now I'm downscaling. 4 divided by 4 gives me 1. I would have to do the same here. 12 divided by 4 will give me 3. So one game costs 3 tickets. I just downscaled. I scaled down. Now, if I were to do 2 games, 3 games, and I gave myself a little bit too much space here in my table, how many tickets would this cost? Well, if one game costs 3 tickets, 2 games cost 6 tickets. 3 games cost 9 tickets. And then I am scaling up doing this. Scaling is when you're going to convert a ratio into another equivalent ratio. If you make that equivalent ratio bigger, it is known as scaling up or upscaling. If you make that equivalent ratio smaller, that is known as scaling down or downscaling. Use scaling. Multiplying or dividing two related quantities by the same number is called scaling, which we just went over. Sometimes you may need to scale back and then scale forward. These are also other terms. So I talked about scaling up, scaling down. You can also call it scaling back or scaling forward. Back meaning it's getting smaller, forward meaning it's getting bigger. To find equivalent ratio. Examples of scaling would be cans of corn are on sale for $10, 10 for $4. This is almost the exact same example I used until I changed that to 12, but go with it. Find the cost of 15 cans. So, if 10 cans cost $4, how much would 15 cans cost? This is where we get in a weird little mode of I can't convert 10 to be 15. I can convert 10 to be a number that then can convert into 15. I can convert 10 to be 5. I do that by dividing 10 by 2. I will then have to divide 4 by 2. So then I know that 5 cans cost me $2. Now, this table is not going to be in order, which is fine. But now I can scale up and turn 5 to 15 by multiplying by 3, which means when I multiply 2 by 3, I'm going to know that 15 cans will cost me $6. So what I did was I scaled 10 to 4 down to 5 to 2, then I scaled 5 to 2 up to 15 to 16, or to 6, because I could not convert 10 to become 15, if that makes sense. There's whole number by which you can multiply 10 to get to 15, so scale back to 5, then scale forward to 15, which is what we did. And it shows us here exactly our steps that we took. We divided 10 by 2 to get to 5. We multiplied 5 by 3 to get to 15. We do the same thing here. 4 divided by 2 to get to 2. 2 times 3 to get to 6. So 15 cans of corn would cost $6. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Is there a whole number by which you can multiply 14 to get to 49? There isn't. We can double check using our calculator and see if 49 divided by 14 will give us a whole number. It's 3.5. That's not a whole number. So, no, I can't make 14 to become 79 or 49. However, I can make 14 to 7, which then I can change to 49. So, no, there's no whole number. But I can scale back to 7, then scale forward to 49. Which is what we do here. 14 divided by 2 will give me 7. 8 divided by 2 will give me 4. So it takes him 7 hours to mow 4 lawns. Then I scale forward. 7 times 7 equals 49. 4 times 7 will be 28. So it'll take him 49 hours to mow 28 lawns. So Joe can mow 28 lawns in 49 hours. And it looks like I already did the got it here, but let's go ahead and erase this for now. And let's try this. A child's height measures 105 centimeters. Estimate her height in inches. Yay! So, a child's height measures 105 centimeters. Estimate her height in inches. What it tells us here is that 25 centimeters is equal to 10 inches. That's what our first ratio tells us. I cannot upscale 25 to become 105. 25 times 4 will give me 100, but not 105. I'm going to scale 25 down to 5 because then I can make 5 105. Dividing 25 by 5 gives me 5. When I divide 10 by 5, I will get 2. So I downscaled, or I scaled back. Now I'm going to turn 5 to 105. If you don't know your 5s, 105, I'm not going to do it here because this pen does not like this, and as you can tell by me trying to erase. So let's use our digital whiteboard. 5 will go into 105, 2 times into 10, 0, bring down my 5, goes in 1 time into 5, it will go in 21 times. I will also need to multiply 2 by 21. 2 times 21, 21 is made up of 20 and 1. Double 20 is 40. Double 1 is 2, so 42 inches. And that is my answer. So we're going to use this example, and then we're going to call this one a video. On our vacation, Leia exchanged 50 American dollars and received 60 Canadian dollars. Use a ratio table to find out how many Canadian dollars she would receive for 20 American. Set up the ratio table, use scaling to find the desired quantity. So, she originally exchanged 50 American dollars and got 60 Canadian dollars. This is how the table is set up. They want us to find out what happens if she exchanges 20. 50 cannot be turned into 20 easily. We downscale 50 to 5. Heck, we could have downscaled 50 to 10 if we wanted to. It doesn't matter. So 50 divided by 10 gives me 5. And then 60 divided by 10 gives me 6. So if we gave them 5 American dollars, we'd get 6 Canadian dollars. We are now going to up-convert this. 5 times 4 will give me 20. I need to multiply 6 by 4. So 20 American dollars will give me 24 Canadian dollars. As far as your homework, class, first answer was there. If you're smart enough to pause it, you got your first answer. So you guys are doing all 8 problems on this homework. Again, if you need any help, you guys can always leave a comment. Message me on Teams if you're in my class. As always, I'm Mr. P, and I will catch you guys on the next one.